Now I just reduced. I didn't take a square root yet. I just reduced. Okay? So this is the ratio of the areas. So how do I get to the scale factor? I take the square root of both of those, which would be this. Which means if the scale factor is 3 to 4, then the diameters are 3 to 4, the circumferences are 3 to 4, the radii are 3 to 4.
They're all 3 to 4 except for area.
Exactly.
Like, I mean, everything's the same except for the area.
Except for area. Area is the only thing that's different. No. Suppose you know you have two similar rectangles. And by the way, all rectangles are not similar. I said that wrong, sorry. Okay. Suppose you have two similar rectangles, and the length of the first rectangle is x squared, while the length of the second rectangle is xy. We can find a scale factor by comparing length to length. But scale factors are written in lowest terms. Can x squared and xy both be divided by something? They can both be divided by x, which gives me a scale factor of x to y. Is x squared divided by x is x, and xy divided by x is y. So what's the ratio of the areas? X squared to y squared. What's the ratio of their perimeters?
X to Y.
What's the ratio of their widths? What's the ratio of their diagonals?
X to Y.
Very good. The only thing that's different is the area. All right. We are going to identify two similar triangles. Then we're going to find their scale factors. And then we're going to find the measure of DC. Okay? Now we already have a way to find the measure of DC. We learned it in the circle, arcs, chords, secants, tangents chapter. Does anybody remember what that is? Are you still drawing?
X and 11 are equal, right?
Nope.
They are tangents.
Oh, you do X times X plus 10 equals 9 times 9 plus 11.
10 times x plus 10 equals 9 times 9 plus 11. So we already have a way to figure this out, okay? But we're going to do it the way they want us to, using the scale factor. All right, first thing we're going to figure out is two similar triangles. But I need two similar triangles that I have a lot of information about. So these two in the middle, I don't have enough information about. Okay? But I do have enough info about triangle ADE and another triangle that is similar to it. But we got to make sure we get the letters in the right order. Okay? So try to help you out to see exactly what we're talking about. Oh, Lordy.
That's good though. I like it.
Now I'm going to have to fix it. doesn't show up. But anyway,
We know.
okay, you get the point. Hopefully. Okay. ADE would be the light blue one. That's kind of showing halfway and not halfway. Is similar to triangle, the other one, the green one. Now, what order is it going to go in? Well, we need to figure out some angles that are equal to each other so we get those vertices in the right order. In those two triangles, what's very obvious?
A is the same.
A is the same thing as itself. Okay, so A and A are going to go in the same spot.
Would E and C be the same?
They would be. Can you tell me why?
Do they look like they would be the same?
No.
They're both on the triangle.
What do you call an angle with its vertex on the circle?
They're equal to the same.
They're both inscribed angles, and they are both creating the same arc right here, BB. And so, two inscribed angles that intercept the same arc are congruent to each other. So C and E. Okay. So we're going from, okay. Which means B and D would be equal to each other. Okay? All right. So now that we have all that mess ironed out, let's find the scale factor of ADE and ABC using two sides that are corresponding, and we know both measures. All right, well, let's look at AD. Do we know that measure?
Yeah, 10.
All right, its corresponding side AB. Do we know that one?
Yeah, 9.
Okay, was 10 to 9. That's my scale factor. Now here's the question. How are we going to use this information to find the measure of DC? You're going to use a proportion. Exactly. If the scale factor is 10/9, then that means, let's see, ADE, that in this triangle, AE, which has a measure of what?
11 plus
20, corresponds to AC on this side, which has a measure of 10 plus X. And how do you solve the proportion?
9 equal to each other.
Cross multiply and divide. 9 times 20 is 180. When you multiply 10 times this sum, you have to realize this is in parentheses and you distribute. So you have 100 plus 10x. Then you solve the equation.
Subtract this times equals 80.
Can you just say like 9 times 2? Equals 10 plus X. Since 10 times 2 is 10.
Okay? Wouldn't it have been a lot easier to use our thing from the circle bill?
Yeah.
No.
Outside times whole thing equals outside times whole thing.
Mhm.
That would have been a lot easier. But now we know how to use the ratio. Okay?
I like the range.
All right. You have a pentagon. You have a pentagon where the 5 sides have measures of 3, 4, 5, 6, and 7. We know the area of this pentagon. We know the area of a second similar pentagon. And we want to know the perimeter of the second similar pentagon. Why do you think they would give us the measures of each side of the first one?
Find the perimeter.
So we could find the actual perimeter of the first one. Very good. Well, what is that? Don't hurt yourself. 25. Okay. Why would they give us the areas of both of them?
Find the scale.
To help us find the scale factor. Very good. Okay? Because